All right, so in section 2, we are looking at trying to organize quantitative data. And so there's a few problems that I want to look at and help you use the technology to help you along the way. When looking at data over here, we're looking at the number of customers waiting for a table at 6 p.m. And so the discrete or continuous, that's definitional. That's something that you're going to find in your chapter. We talked about some of that, I believe, in chapter 1, just talking about the data. But we have some countable things on how many people. So we would be looking at discrete data. And it's going to ask us, number of customers from 1 to 3. What's the count? So we have a whole bunch of numbers here, and I'm going to open this in StatCrunch and show you a way to do it. So if we make StatCrunch is opening, we could do a physical count, with 1 to 3, 4 through 6. So a whole bunch of different ways to do this. And we'll see those different ways. See if it's StatCrunch somewhere else. All right, so I had to make sure my pop-ups were turned on for my StatLab. But I have a whole bunch of data here. What I could do, if I wanted to, is I could sort my data. And I could put it in ascending or descending. And so now it's going to be a lot easier to get those counts for the frequencies. Like there's only 1 in the 3s. There's 4, 5, 1, 2, 3, 4, 5, and the 4 through 6s. So that is a way to help you sort that information over here when you're given a whole bunch of data. We're looking at graphs, something that could be done, like if you're doing a bar plot, and we actually have data here. We don't have a summary of the data, we have the data. We could make a bar plot, and we hit compute. Here's a way of getting the counts of each one of them, right? So we could see at 3 we have 1, 4 is 1, 5, 1, 6 is 3. So that would be an easy way to count them as well. Kind of fan of doing it this way, I guess. We could also do something that's in section 2, is talking about histogram. Histograms are more for continuous data, but we could start it at 1, and we would have the width be 2, so that would be 2 more than 1, right? So let's see what we get here. Oh, so that says, now with 3, since we want to include 3, we might have to edit this. Again, this may not be the best way to do it, but it is a way to do it. We would go from 1 all the way up to 4, but not counting 4. So this gives me from 1 to 3. This gives me from 4 to 6, not including 7, because that cutoff, that upper piece is further to the right. So several different ways to help figure out these numbers. So I'll use this one. Let's see if I can get it to label some things for me. To count. See if that helps me out some. Not really. Did kind of break up that, which is neat. So here I have 1. Over here I have a frequency of 5. This one I'm all the way up to 14. This one I have 15. And then it looks like I'm back to 5. And so that helped out a little bit. Not sure why my screen went pink, but it's a pretty color. So I can check my answer, and it says, good job. Relative frequency. Now, if you're doing a relative frequency, in the past section, we talked about how that is just it's a ratio. So it's this number over the total that we've had here. So the total of numbers that we had looks to be 40. So this would be 1 over 40, and that would be the percentage that I would put down here, or the decimal number. So we're not actually typing in a percentage. So 1 out of 40, using whatever calculator you use, you could do that to help figure out those percentages. That is going to be a guide to get you to use some of this different technology, whether it's a sort for your data. I know in the last section we had used some tables. We did some graphs of pie charts and bar charts. So something that we can use. And number 10, here they give us some data and they want us to put it in a frequency distribution. And they told us they want us to group 0 to, so we have a class limit of 0, so that's where we're starting, and a width of 0.5. Just want to bring up the text, and when you're doing this, right, so we always should be looking at the text first and reading it. We're going to be able to figure out how to divide up our classes and what a width stands for. So the width of each rectangle is the same as the rectangle touches each other, so that's in the histogram. Let's get to those formulas. So we have our lower class limit as the smallest value, the upper class limit is the largest value, and the class width is the difference between the lower class limits. So between 25 and 35, that's 10. That would be our class width. So when we go back to the problem, if we're looking from, 0 to 0.5, right, is our class width, that would be this value down here. That means I would go all the way up to 0.49. So again, to find those values that are within that range, if we open this up in StatCrunch, again, we could sort the data. Maybe bin it. This would be good. Start with 0, and you want it to be 0.5, and let's see how that works out. I have to select a column. And so, that tells me which one it's in, right? 2.5 to 3. So that's actually good information, because that is something that we could then make a frequency table out of. That'd be kind of fun. From our bin values, let's see how that does. And it gives us some counts, right? So again, be aware that we would go from 0 to 0.49, but then 0.5 to 0.49. The class width goes this way, 0 to 0.5. But we can use the technology to help us kind of fill some of this stuff in, so we'd get a frequency of 4. The next one would be from 0.5 to 0.99. And that says the frequency is 9. And look, we already have our relative frequency if they asked that. So that was a beautiful discovery, right? Having StatCrunch work for us. And that's going to make this process a lot easier on number 10. So these are my bins, right? The width is 0.5, so I'd go from 0 to 0.49. The reason why StatCrunch is not doing this is a whole bunch of different algorithms, different ways that we do things sometimes in stats. So we just have to be appreciative of those different ways and willing to adapt. Another one, they just had a graph of something. So again, importing that data into StatCrunch, they're looking for a dot plot of the data. Well, luckily enough, I have a dot plot that I can use. And when I do that, it gives me my counts for, 0, 1, all the way to 5. And so then we're just kind of matching things up. Very rarely in today's world would you have someone actually do this by hand. You're going to use technology to do it. So making sure we are using our technology for these problems and easily moving them to StatCrunch to aid us with these problems.